So the first part of this video is to explain the true and false questions at the top of the page, and I went ahead and copied the quadrilateral family tree to help us go through whether these are true or false. So all squares are parallelograms. Now, since square is below parallelogram, that is a true statement. All squares are parallelograms. Now, the second one is saying all rectangles are squares. Now, that's not necessarily true. If I go down the tree, not all rectangles fall under the square category. They might be, right? Some rectangles are squares, but not all of them. That is false. All squares are rhombi. That's true. All squares fall under the rhombus category. All rhombi are quadrilaterals. That's true. On this family tree, rhombus falls under the quadrilateral category. A rectangle is a parallelogram. That is true. Rectangle falls under the parallelogram category. All quadrilaterals are rectangles. That is false. Some of these quadrilaterals could be a rectangle, but that's a specific type, right? Quadrilateral, if I have to go down the tree, only some of them. Only some, not all. So that's why it's false. Now the rest of these have us go through solving for missing angle measures, so I'll zoom in a little bit. Rectangle is probably the hardest. You have to use most of the properties that we talked about together. I'm going to go run and grab a calculator and be right back to explain those angles questions. Okay, I'm back. This first one is a rectangle, so I can use all the properties for rectangle that I know. The first thing that I know is that I have two different pairs of isosceles triangles here. This top one is an isosceles triangle, and it's identical to what's on the bottom. So some stuff that I can start to fill in. If this angle is 27, put in our isosceles markings here, I know that angles that are across from or opposite from congruent sides are also the same. So this 27 is congruent to this other one down by J. These two triangles are identical. So I know that angle 2 is also 27 degrees, and so is angle 1. I can do the same thing with 126. These are vertical angles. Angle 5 is 126. I know they didn't ask me that if this angle was 27. I just find it helpful in finding all the missing angles instead of just finding the ones they asked for, instead of just picking and choosing. The other problems are very similar, okay? One of two ways you can see this. Here's the way I see it to be a little bit easier. One thing that I know is the corner of every rectangle should make 90 degrees. Now I know I have a 27 degree angle there so far. So if I take 90 and subtract 27, I'm left with 63 degrees. And again, this triangle is on the left. This triangle is isosceles. So there are congruent angles across from the congruent sides. If this angle is 63, so is angle 6. Two ways I can find angle 4. It depends how you see it, how you feel comfortable solving this problem. Okay, the first thing that we can do is we can say, okay, in in the center here, I have a linear pair. The 126-degree angle I have makes a straight line with the angle I want. Linear pair is supposed to add up to 180. So what I can do is I can say, okay, well 180 minus the piece I already have will give me what's left. Will give me angle 4, will give me what I want. So angle 4 is 54 degrees. That says 54, sorry. Another way you could have solved for this is you could have said, okay, this left piece right here is a triangle, which I know has two 63-degree angles. If I add these up and subtract it from 180 from the sum of a triangle, I can find the piece I want. I find the linear pair to be easier, but again, it's your personal preference, whatever you feel most comfortable with. Both of these triangles are identical, so I can go ahead and copy. I can pretty much flip all of those numbers over to this side. So things that you can use when you're solving inside rectangles, you can use triangle sum, you can use isosceles triangle properties, you can use the fact that the corners should make a right angle, you can use linear pair. All of these things are written on the sideboard up at the front of the room under rectangles in orange and also under parallelograms in blue. Next we have a rhombus. When we are solving for angles of a rhombus, what you need to keep in mind is that we have a lot of rhombus properties to apply here. So the first thing that I always do is I know the diagonals of a rhombus are perpendicular, which means all of the angles in the center here for a rhombus, all of them are right angles. So all of them are 90 degrees. Another property of rhombus that I can use, I'll use it once in the beginning and then once at the end. It kind of just depends how many angle measures you have filled in. But I know that every corner of a rhombus gets cut in half. If this piece I have so far is 53, that's a half. Right? That's a piece of this angle. The 53 is the same on the other side. Right? Those angles got cut in half. I had one. Other piece is identical. I also know that both of these values are the same on the total other side of this rhombus. Opposite angles are congruent. 53 means over here I have a 53, which also means angle 12 has got to be 53. And then I have a bunch of triangle sum problems. So I'm going to highlight one of them. Within that pink triangle, and it really didn't matter which one I chose, all of them are going to be the same, but in the pink triangle, I have a 53-degree angle and a 90-degree angle. It's supposed to add up to 180 degrees in here. So I'll add 90 plus 53. 90 plus 53. And I have 143 degrees in this pink triangle so far. I need to know what I'm missing to get to 180, right? 180 minus 143 is 37. Angle 9 is 37. The other side of angle 9 is 37. And both of the pieces across this rhombus, including angle 11, are both 37. So with a rhombus, you need to use a lot of properties here. You need to use the property that the diagonals meet at right angles. You need to use the property that they cut the corner angles in half. Solving for a square, that's probably the easiest bit, just because it uses all the properties we've seen up to this point. The first one that I always write in is the diagonals are perpendicular. Diagonals meet at 90-degree angles. All of them are 90 at the center of a square. I also know that the corners of a square together would make 90 degrees. But just like we did in rhombus, these corners get cut in half. Half of 90 means angle 13 is 45 degrees, angle 14 is 45 degrees, angle 15 is 45 degrees. If on a quiz I asked you for the measure of angle UTS, that's asking you to put the entire corner together. Angle UTS is 90 degrees.